Hi everyone, this is our session 2 in the series of 6 lesson, right, where we will be talking about Python for network engineers, right? And for in this lesson 2, we'll be primarily focusing on data structures and the functions um, in Python. Okay, so data structures, we'll talk about multiple data structures which are present in Python, right? We'll start with discussing what is basically data structure, right? And then we have multiple data structures like list, dictionary, set, tuple, right? All of these basic data structures in Python. And there are some more complex data structures which can be built, based on these basic data structures, like graph, tree, linked list, and more. Okay, but we won't be discussing that in this session, right? Because those are more complex data structures, right? And talking on one of them will require 1 hour of session each, right? So we'll not be concentrating on them, right? And before going and talk, second topic we'll be talking about is functions, right? So functions is a way of writing code, right? Writing modular code in Python so that we can use one piece of code multiple times. Okay, so how to do that we'll talk in this lesson 2. But before starting this lesson, right, let's discuss the solution of the problem which we left with in lesson 1, right? So this was our problem, right? And that we have this raw lines, okay, basically some output of show interface, right? And we want to know this kind of whether whether it is an what's the status of admin and the line status, right? And based on it, is it okay, or we need checking the cable, or it is a disabled, or it is unknown, right? So let's discuss that, right? This is the same raw lines, right? And if you see here, right, the raw lines, this is basically a list, right? We'll discuss it today in detail, but this is basically a list. Okay, list is because this has multiple entries. Okay, this is not one single variable, correct? This variable has multiple entries. Okay, now I have defined some variables, right? Okay count, check count, disabled count, and unknown count, right? Because I wanted to know the count as well, right, in the end. Now for line in raw lines, right, this is the for loop which we discussed in the last session, right? So what I'll do is I will loop over these lines. Okay, what does looping means? You give me line by line. Okay, so first give me this, in second iteration give me this, in third iteration give me third line, in fourth iteration give me fourth line, right? Just to remind again, the counting starts from 0. So this is 0, this is 1, this is 2, this is 3, this is 4. Okay, so I'm taking line in raw lines, right? Now I'm splitting those lines, right? Splitting as in I am breaking it, right? So when I want to break it, I have to give it some delimiter, right? And when I'm giving a empty delimiter, that means it is basically empty space. Okay, one empty space. So basically it will break this single line into 4 different parts based on a space. Okay, so we have one, this space, and this space, right? So this will be our first, this will be second, this will be third, and this will be fourth. 4 variables, right? So you see there are 4 variables: name, admin status, line status, and mtu raw, right? What if we only define 3 variables? It will give an error, right? Because for unpacking this we need 4 variables, right? So for it will throw in some error like cannot unpack this, something like that. Okay, now this is a string, this is a string, this is a string, and this is also, when it breaks it becomes a string, right? It is a string only, correct? But we want this to be a number, correct? Because um, 1500 required in form of number, right? So we'll do typecasting, right? We'll convert it into a number. Okay, remember that this is an entire string, and if we break a string, again the output will be in the form of string only. It will not be in the form of integer or anything. Okay, now then next I'm using if loop, if statements, right? If else, right? So you can see it is if, elif, and then else. Okay, so I'm saying if admin status is up and line status is up, then classification is okay. Okay, and okay count I'm increasing by 1. Next else if this means else if, but just in short form it is written as elif in Python. Okay, elif admin status is equal to, remember there are two equal to, okay, not one equal to. One equal to is used for assignment, two equals to is used for checking the value. Okay, equality up, and line status equal to down, I am saying check cabling the count plus 1, right? Then I'm saying admin status equal to admin down, Okay, here I'm not doing to and or, right? I'm just checking if the admin status is admin down, that means the interface is actually disabled, right? So I'm saying classification is in the disabled count is equal to +1, right? Else anything else, right? So if else will catch everything else. Okay, so if suppose say due to some error, right, we are not getting any value here or here, right, or some null or none something else, right? So it will catch everything and we'll say that uncount +1, right? And while I am doing all this in the for loop itself, I am printing it also. Okay, I'm printing that this is the interface, right? Admin is this up or down, line is this up or down, and the MTU is this number, and what is its classification. Okay, check cabling disabled and unknown. Okay, this count I am just doing it, I am not printing it here. Count I am printing based on the output here. Okay, so I can see that total length of row lines, right? Length of row lines is the number of lines in my list, right? In my list I have 0 1 2 3 4 5 5, but counting starts from 0 to 4. Okay, just reminding it again, right? So it has five members, right? So total, so I'm saying okay count is this 2, check cabling count is 1, disabled count is 1, and unknown is 1, and total is 5, right? So this is basic, which we discussed in our last session, right, in session 1. Basic for if statements, right? How to print them, how to do typecasting and all. Okay, if you have not seen the first video, please, I would recommend to go ahead and watch the first video first, right? Because it will contain few topics which will require to build the fundamentals here in lesson 2. Okay, if you are already comfortable, if you are able to understand all of this without uh, going back and looking into something, then you understand most of the stuff in lesson 1 and we can just go ahead with lesson 2. Okay, but if you're not able to understand anything, even one part of all this, right, I would highly suggest to watch lesson 1 first. Okay, now having said that, let's go to the lesson 2, right? And here just reminding, starting with one reminder which we did in lesson 1 also, is how to view our variables, right? um, uh, because our whatever data structures we'll be using, those will also be variables. Okay, so when we are saying a variable, right, a variable is not a box, right? In first session, right, for easiness of understanding, we said that it is like a box which holds a value, right? But remember that a variable is a label, right? And if you, now we have understood that lesson 1, so now we have to go a little bit deep and understand that variable is like a label, and that label is pointing to somewhere inside the memory, right? We discussed about memory and all also in lesson 1, correct? So multiple labels can point to the same object, right? We, you know that we created variable a equal to 5, and then we said b equal to a. So actually a and b are both the same labels for value 5. Okay, and if you do, if you check their memory, right, actually they are pointing to the same location. Okay, so if you modify the value, right, you are modifying the next value also, right? uh, Depending, right, whether it is a mutable or an immutable, correct? uh, Right. We discussed in a last session also, right, where we took running configuration, right, and copied it into a backup configuration, correct? So understanding this variable is very important, because what we'll do is we'll be copying one variable into another variable, right? And then we'll be saving that variable for some another use, right, another use case, correct? And we'll be modifying the new variable, right? If you don't understand how these variables are working with each other, those can cause a lot of bugs and issues basically. Okay, which will be which can take a lot of time to fix, and a lot of time to troubleshoot. Okay, so it's better if we have that understanding from beginning. Okay, so for example, we have an interface here, right, and I have created a backup of interface, right, and I am appending the backup, I am appending in backup, right? But actually when I'm appending in backup, it is also appending in my main interface, right? My original intention when I'm writing for backup is that it should copy in backup only, it should not copy in my main interfaces, right? That's why I created a backup, right? But it changed my original interfaces also, right? So that is not what we wanted, correct? So that's, we decided that instead of making interfaces, we have to do something like interfaces.copy, right, which will create a copy. This is not a copy. We, our general mindset will be like, this is a new copy, backup is a new copy, right? But you see both of them are pointing to the same memory location, right? So they are basically inherently the same object, right? To fix that, we should try to use copy, right? Copy will create a new copy, right? And interfaces is backup, right? We discussed in last session that is checks the memory, right, whether both of them are exact same object, right? and equal to checks that both of them have the same value, right? So if two interfaces equal to backup, actually it will be same because interfaces and backup both have the same value, right? But they have the different memory location. They are actually pointing to different two different objects, right? So the interface is backup will give us false, right? And that is what we wanted, right? We wanted that backup should be a copy of interfaces, and when we modify backup, it should not modify the original interfaces, right? So never copy a mutable object using equal to, right? It is just another label. Okay, depends, right? As we talked, it depends either whether it is a mutable object or an immutable object, right? If it is an immutable object like a string or integer, right? If you assign it to another variable, it is basically a new variable, right? Because it is immutable. But if it is a mutable object, assigning it to a new variable is just like creating a new label. Okay, I use copy to make a new copy of it. Okay, if you want to create two labels to the same memory, it's fine, right? It's depending on our use case. Okay, now let's start with all the data structures. Okay, so what first, let me we have not written it here, but let me discuss, right, what is data structure first. Okay, so here suppose we have maybe say 10 devices in network, right? And in those 10 devices, I want to store the running config of all those 10 devices. Okay, so now what I'll have is, I will have a device name, and mapping to that device name, I will have the running configuration of that, right? So let me bring a notepad. So to just okay, so we have something called as, say, we will have the R1, our device name, right? And that will be pointing to something, some running config one, right? Some running configuration one. Then we'll have an R2, right? Which will be pointing to some running configuration two, right? Say R3, which is pointing to some running configuration three. Pointing as in it has running configuration three, right? Now I need to store all this data, right? So what I can do is, I can create one variable R1, right? And I can create one variable run1, right? And then I can create another variable R2, I can create another variable run2, I can create R3, I can create run3, right? And then I will have to keep in my mind that run underscore 1 is actually the running configuration for R1, run underscore 2 for R2, run underscore 3 for R3, right? It is also possible to do this. But it is like not, it's not impossible to do this. Okay, now imagine that there are 10,000 devices in network, right? You will have to define 10,000 of these R1, R2, R3, R4, R5, R6, R7 till R1000, and similarly run 1, run under 2, run under 3, and till run underscore 1000, right? And you'll have to remember that R1 maps to run underscore 1, R2 maps to this, R3 maps to this. All of this have to be some understood, documented somewhere, right? Now, rather than doing this, what I can do is, I can create a list, right? We'll talk what list is and everything, right? But just I want to share why, what is the need of a data structure, right? To organize the data, right? We have some data, we want to organize it. How to organize that, right? So we want that we will use a list, and inside that list we will use a dictionary, right? Dictionary will be a key value pair. Okay, so we'll have a key of R1, data of a value of run1. Okay, we'll close this dictionary. Okay, next dictionary will be R2 and data of run2, right? Now R3, data of run underscore 3, right? I'll close the list. Now what happens here? I have only one variable. Okay, the variable name is router configs. Okay, under router configs, in one single variable, I can score thousands of what you can say router configurations, right? And each of them mapping it properly, right? So I have a list of router configs basically, and inside one list we will have one run configuration mapping to one router mapping to one running configuration, right? We can make it more complicated. I'm just saying this is one of the basic, right? So a data structure is just created so that we can organize the data in a particular format, right? And to reduce the creation of maybe say multiple variables, right? And how those variables interact with each other, right? For example, I have to remember that R1 variable is actually a router name, and run1 underscore 1 is basically the running configuration for that R1, right? So all that understanding I have to keep, I have to document. Rather than doing all that, I can create data structures, right? and integrate that all that understanding, integrate all that logical relationship in the data structure itself, right? So that is the what power the data structures provide to us, right? And what we'll be discussing today are the basic data structures which are inbuilt in uh, mm, Python. There are some more data structures which are already inbuilt through packages like tree and all, right? And we can create some data structures on our own also using the basic data structures. Okay. Definitely tree, list, tree, queue, stack, right? All of that can be created using the normal data structures, right? But we'll not be going into that. Okay, those are even more complicated way of organizing data. Okay, so first of them is list. Okay, now for list we have to understand this is ordered, mutable and indexable. Okay, ordered means there is an order, right? We said, right, it's 0 1 2 3 4, right? So it's starting from 0 and it is ordered. Okay, so it is ordered, it is mutable. Okay, mutable means we can change it. Okay, we can modify that data. Okay, so if we want that at a particular position, I have to modify that specific data, we can do that. Okay, so it is modifiable, it is mutable, it is ordered, and it is indexable. Indexable as in, as we said, right, is we have index 0 1 2 3 4, right? So it you can think it like the current list of interface on this device, right? So ordered position matters, right? As I said, mutable, you can add elements. Indexable, you can index it basic using 0 minus 1. We discussed about indexing last time also, right? So it's basic, we can index it also. Okay. Heterogeneous means we can mix multiple types of data. That means it is not compulsory that if you have list, so you should have all. If it is a string, so you should have all strings only in the list. You can mix string, numbers, other dictionary, other lists, anything. Okay, so this is our, say, a list of interfaces, right? This is 0 element 1 2 3 4. Okay, so z starts from 0. Then you can start from minus 1 also. This is minus 1 minus 2 minus 3 minus 4 minus 5. Okay, if you want data, you can take data from 0 1 2, 0 till 2. So 0 till 2 is this. Okay, last one is removed. So if you say 0 to 0 till 2, so 0 and 1. Okay, so this is 0 element, right? First element, minus 1 is last element. 1 to 3. Okay, 1 means 0 1. This is 1 1 2 3. So last element is not including. Okay, this is last element is not including. Okay, so 1 till 3 means 1 and 2. Okay, 1 till 5 means 1 2 3 4. Okay, so 1 till 3 means 1 and 2 excluding 3. Okay, and length means how many, what is the length basically. Okay, now I can add, I'm doing is I am appending it, right? When I append, I am adding the VLAN 10, right, in the beginning, sorry, in the last, correct? And when I'm doing insert 0, that means I'm inserting it at the 0th location. Okay, so this is 0th, so this all everything will move ahead, so it will come at 0 0 1, right? So it will move ahead like that. Okay, then next is when I am remove by value, right? If I have to remove a specific value, I can do remove. So for example, I want to remove L0, I will do remove L0, right? Now L0 is removed, correct? I want to pop means removing the last element. Okay, then I'm printing and I popped this value, so I kept it here, correct? So this is what how we can use list. Okay, now one of the other thing is how to use list comprehension. Okay, so this is used for building a list, right, or transforming some filtering, doing some kind of filtering on this list. Okay, so there is then the original way or the old way of doing it via the for loop. Okay, we can do it via some list comprehension also. It is a Pythonic way, basically called as a Pythonic way of doing it. Okay, the time taken for both list comprehension and for loop by the program itself, right? How much time it will take, both of them will take around similar time. Okay, list comprehension is slightly better efficient, but in our normal Python program, right, which we do, correct, for network engineering perspective, both of them yield the similar result. Okay, so one of them is fine, but this makes the code more clean, more precise. Okay, more short. Okay, so for example, I have these raw interfaces, right? So I want that for I in raw interfaces, if the interface starts with gigabit, I have to append it to the old interface, right? So this is this. I want this. I want this. I don't want other. I want only gigabit Ethernet. Okay. So this is one way of doing it. Okay. Another way is what I can do is this is called as list comprehension. Okay. What I can do is I can do I for I in raw interfaces if I dot starts with gigabit. Okay, so this I in raw interfaces, okay, this I in raw interfaces is basically this I in raw interfaces, right? And I'm saying I means I am saying you put only directly the value of I. Okay, if I want to modify anything in this I can do here I dot replace. Okay, so filtering transformation happens here and filtering happens after if. Okay, so I want to do any transformation I can do on this I can say I dot I can capitalize it, I can small it, right, I can trim it, whatever I can do. Okay, for I in raw interfaces if statement, right, if I starts with gigabit, that this means that in this list put I, right, for all the I in raw interfaces, means for all the value in raw interfaces if that value starts with gigabit, right? And if I want to do any replacement, right, I can do it here. For example, I did I dot replace gigabit ethernet replace with gi, right? So any transformation can be done in the beginning, any filtering will be done after if. Okay, normally. Okay, now why this matter, right? Now understand that just talking about what we called as big O notations, right? Whatever we are talking here, right, we have to understand from the data structures, we also have to understand how much time each operation takes for any thing in any data structure. Okay, that will help us to finalize later, right, which data structure to use for which use case. Okay, so for accessing anything by index in a list, right, it will take an O of one time, right, because it in an instant, right, whatever is the size of your list, right, if you want to access anything, right, you can access it directly using the index, right, you can say O of 999, right, or O of 500, right, even in the list of 1000 device, accessing any one device with its index is instant. Okay, accessing anything adding anything in the last is also instant, right, because you already have a list and anything you want to add in the last is just like adding anything one thing at the last, right, so it is an instant. Now inserting at front or basically inserting it anywhere in between, right, it is order of n. Why order of n? Because you have to insert it there and then move all the other elements forward, right, because if you saw above, right, if when I'm inserting gigabit ether, when I'm inserting this in point in position 0, right, I am inserting it in position 0 and then I'm moving everything ahead because I'm moving this in position 1, this to 2, this is to 3, this to 4, this to 5, right? So basically I have to touch each and every value. Okay, uh, search by value, search by value is also of order n. For example, if I have to search by any value, then so I have to basically touch all the elements, right, to see if that value, if I have to do remove by value, that is also of order of n. Okay, when to understand what does big O means, from not going to not making it very complex. Okay, we can it's basically called as time complexity. Okay, means how much time anything takes to work. Okay, any action takes how much time. Okay, to understand it from network engineering perspective, you think that how much time it will take, how many element does it touch before taking any decision. Okay, for example, if I am saying access by index, for accessing anything directly by index, how many elements I have to touch? I have to touch only one element, right? Because I know the index, right? Appending to end, right? When I'm saying at the end, I have to add an element. How many element do I have to touch? That one single element, right? And I added it at the end. Now, when I have to add it in the beginning, right? How many elements I have to touch? I have to touch all the elements, right? Because I have to move them one by one next, right? So I have to touch all the elements. When I'm saying touch all the elements, it becomes order of n, right? And don't think that if I'm big in the starting, I'm adding the elements, so it will take order of n. If in the middle I'm taking, it will take order of n by half, right? It is not like that. Okay, think it from the scale perspective. There are 10,000, 20,000 elements, right? So we will say generalize, it will take order of n if you want to add it anywhere in the middle. If you want to add it in the end, order of 1, in the middle, order of n, right? Now if you have to search anything, basically you have to search all of them, right? You have to search so this time complexity, I'm taking the worst case time complexity. Okay, always in general in programming, worst case complexity itself is taken, okay, not the best case complexity is taken. So in the worst case I have to check all the elements. In the best case I will find it in the first element itself, right? So I'm not taking the best case, I'm taking the worst case, right? Because our programming should be in perspective of best worst case, right? If we can't program in the format of the best case, okay. Next is tuples. Okay, so for tuple, a tuple is also like a list, but list is mutable and tuple is immutable. Once you have created a tuple, you cannot change it. Okay, so why cannot be changed? First is correctness. Correctness, as in uh, tuple acts as can be used as a source of truth. Okay, that means once you created that source of truth, you cannot change it. Okay, so it basically prevents immutability. That means it prevent mutability. That means you cannot change it once created. Okay, so there will be no bug. Okay, for example, you want that for a IP prefix, right? Or you should have a fixed record for a specific router or device, right? You want that nobody should be able to change it once created. Okay, or if you want to change it, first create the first one, then create a new one. Okay, so in that case you can use a tuple. Then they are hashable. Okay, hashable as in basically they can be used as dictionary keys. Okay, understand that operations on tuple will be faster than operation in list. Okay, list cannot be hashed. Okay, this is my IP mask, IP and mask. Okay, so this is my IP address and this is my mask. Okay, this I have printed, right? If I want to modify the IP mask, right, IP address, right, I cannot do it. This is not allowed. Okay, this will throw an error. Tuple does not support item assignment. Okay, and we can use list, we can use tuples as a key in the dictionary, as I said, right? It is hashable. So anything which is hashable can be used as a dictionary key. Okay, so you saw that I cannot modify anything in my tuple. Okay, so that makes it powerful. Okay, uh, next is set. Okay, this is what I already talked about, order of n worth reading. Okay, so you can give it a read. Then next is set. Okay, set is unordered. Okay, now like list, it is not ordered. Set is unordered, but it contains all the unique items. Okay, and it is created for two main things. First is eliminating all duplicates. You cannot have two duplicate things in the tuple. For example, you can use it for MAC addressing, you can use it for router names, where all router names should be different, right? It should not be two router cannot have the same name. Or you can use it for storing IP address, where two different IP address cannot be same, means IP address pool, right, where all the IP address should be unique. You can use it to store it here. Okay, just a few examples, right? And second is for membership test. Okay, membership test means finding, right, whether this belongs in this set or not is instant. Okay, so suppose I created this list, right, and when I'm converting this list, this is this and this value are same, last two values are same, right? So when I will convert it into a set, it will become unique. So it will have only these two items, this and this. Okay, but do not, if this time it is printing this, next time it can print this two first and one later. Okay, so remember that we cannot use it for, if you want it in order, you cannot use it set. Okay, set is an unordered set of collection. Okay, but checking whether a particular name is already there or a particular value is already there in the set is instant order of one. Okay, in list, checking if a value is present in the list, as I said, is order of n, right? But checking anything in a set is order of one. Okay, suppose you want to have store it, you use it for storing a set of router names, right? And you want to see that I am creating a new router name, router 100, whether that name is already present or not, right? So if I use set, I can find instantly, no, R100 is not there in the set, or is it present in the set. But doing that in the list will take time, will take order of n time. Okay, so that is the advantage of set. Okay, suppose I am doing and we can do mathematical operations also on set. Okay, which is one more important thing. For example, I have switch A VLAN, I have switch B VLANs. I can do a difference of those VLANs. Okay, so I can say which VLANs are present, switch A VLAN minus switch B VLANs. Okay, so if there is any VLAN which is present in B, remove it from A. For example, 20 is there, 30 is there, so I removed it, right? So I have only 10 and 40, right? I can do on both which VLANs are there on both, right, and which VLANs are there both combined, right? Means either. Okay, so or, and, either, all of that can be done here. Okay, using sets. Okay, uh, as I was mentioning, set is unordered, so you do not rely on printing it in ordered form. Okay, so if you want that, it should be in ordered format, right? That means your code is depending on order. Don't use sets. Okay, because it will not be printed in order. Okay, now let's see next. One of the most important concepts, right, which will be using which data structure is dictionaries, right? And it will be used widely and continuously, okay, in network automation. Okay, dictionary is mapping keys to values. Okay, so this is key, and after this colon it will be value. Okay, and lookup, in this lookup as in finding anything in this, is order of one time. If you know the key, you can find that value instantly. Okay, so set also, we said we can find anything instantly. In dictionary also we can find anything instantly, or both are order of one. But in set you can have like a single values. Okay, in dictionary you can have a key value pair. Okay, so this is my key, host name, value, this key value. All key values are separated by comma. If you forget comma, you will get error. Okay, now I want to do device of host name. I want to find the host name from this device. I can do it instantly. This is order of one time. This is what we can do. If you don't want to use this brackets, you can use dot get also, right? This fails. Okay, this will crash if there is no key like host name, right? If there is no key like, say, this key does not have a key of IP address, right? So if you do device of IP address, it will fail, it will crash. Okay, but if you use dot get, okay, then it will not crash, because it will return none if it is not present in this dictionary. Okay, if you want to return a particular value, you can use unknown. Okay, this will return unknown. You can modify any keys. You can say host name, changing what to host name. You can say device of host name is core switch 02. It will change that host name, right? You want to add a new key, you can add it immediately. Okay, so addition, deletion, modification, retrieval, if you know the key, it is order of one instant. If you don't know the key, then it will be order of n, but mostly we'll know the key, then only we will use dictionary. Okay, our use case will be such that we know the key and we want to find that value immediately. Okay, now all these data structures can be nested within one another. Okay, so as we know that whatever output will take from the device, for example, the configuration which the example which I gave in beginning of device mapping it with their uh, configurations, right? It was a list, and then in that list it was a dictionary, right? So most of the time we will be nesting this data structure. Okay, nesting means putting one data structure inside another. Okay, so this is the routing table, right? And this routing table is basically a list, right? And in that list I have dictionaries, multiple dictionaries. Okay, so this is a dictionary where I am network next hop protocol metric, network next hop protocol metric. So this is a list. Inside that list it is a dictionary. So this is a list of dictionaries. Okay, and we can have a dictionary of lists also, no problem. Okay, where we can have a dictionary and we can have value, some key, and with that key we should have some value. Okay, so list cannot be a key. Key can only be things which can be hashed. Okay, so string can be a key, a set can be a key. Okay, but a list cannot be a key because list is not hashable. Okay, then like we had list comprehension, we can use dictionary comprehension also, right? We can say route of network equal to route of next hop for route in routing table. Okay, we can do list comprehensions, right? uh, Multiple things, right? For printing, say printing, you want to print this next hop, right? You can say routing table, this is 0, this is 1, so you can say routing table of 1 next hop, right? So that way we can do it. And here as I said right earlier, we can use a string as a key, and we can use another dictionary as a value, or we can use a list as a value. So this is a dictionary of dictionaries. Okay, so like this way we can do we can create complex data structures, right? And then use it for our specific use cases. Okay, now when to use what data structure, right? So first, if do I need duplicate, and do I care about order? So I have to use list. If yes, both of these are yes, right? This is a general script, right? Uh, is this a fixed small shouldn't change record? This is a small record which should not change. Yes, it's a tuple. Do I only rely for uniqueness, right? I just want to find values. Is this present in this? Is this present in this? Only that kind of checks. So I can use set. I want to find values instantly, right? Using key value pair. I do not care where what is the position. I can use this dictionary, right? If there are multiple similar kind of record, right? If I want to jump directly to a specific record, I can use the nesting list of dictionary, dictionary of dictionary of dictionaries, dictionary of lists. Okay. So these data structures we discussed, right? List, tuple, set, and dictionary. For important ones, like at least list and dictionaries are the most important part. Okay. Next, we'll start talking about functions. Now again, why do we need functions, right? So function is required so that say we want to use a particular piece of code again and again, right? Writing that same block again and again, we can just create a function, right? And use that function everywhere. Okay. So for example, you want to create a function for addition. Okay, addition of two numbers. Okay, say add, right? R1, R2, right? And these are strings. Okay, so what you will do, you will first convert them into number, right? You will first convert them into number. You will convert the second one into a number, right? Then you will add R1 plus R2, right? Now if you want to add any time, right? Because you know that the values which are returned from the device CLI, right? Those are mostly whatever we are returning from the device CLI, mostly these are coming in the form of a string, right? So anytime you want to do addition, you have to do it like this, right? First convert that string into a number and then add them, right? Now say you want to do this 10 times or 20 times in your code, right? Every time you have to write the same code again and again, right? You convert them into integer, you convert them, then add them. That is the way, right? What if I can make a function out of it, right? I can say def add, right? And R1. Okay, I can say R2, and from here I have to return just this value. Okay, now from outside how it will look, say from outside I can just say add R1 R2, right? So R1 and R2, I don't have to care about that these are string anymore, right? I can just pass this to this function add, right? This function will add them, convert them into list, convert them into integer, add them and return me as an integer, right? So all these three lines which I had to write maybe say 10 times, 20 times in my code, right? I made a function out of them, a reusable block of code, right? And I told this function to do a particular task, right? And return the value to me. So that I can, instead of doing that same part again and again, right? I can create a function out of it, and that function can do the heavy lifting. It can do that work. Okay. Uh, so yeah, say yeah, the first example is pass. Pass means don't do anything. Okay, so just I've shown this as an example. Okay, pass. If you just write pass into a function, it means that do not do anything. Okay, and just pass that. Okay, and you can see I'm doing some task, right? Return up in status line lower and down not in status line lower. Okay, uh, basically this is doing short circuiting, which we discussed last time, not discussing it again, right? But just remember that this is a definition, it is returning something. Okay, and it is not compulsory that every time a function should return something. You want to do something in the function and don't return something, that is also fine. For example, you want to print, do some logging, right? You can create a logger function, you can pass some data to that logger, and you want that it should print it in a particular way, you print that from that logger and do not return anything. Okay, that is also possible. So function should not return anything. It is not compulsory that it returns something every time. Okay, and you can create a function with some way passing some variable, and you can create it without variables also. For example, here you don't have to create any variable. Like here we don't have not passed any variable, but here we have passed a variable, right? Status line, and this variable is then used inside. Okay, now remember default arguments. Okay, so this is the default argument. The status line is a compulsory argument. Compulsory argument as in you have to provide status line. Without, if you have created a function like this, right? If you don't create a status line, if you don't pass this status line value, you this function will not run. It will throw some error. Okay, but you can have default arguments also. Okay, so this is in this function VLAN ID is the value which is always required by this add VLAN bad. Okay, but VLAN list is a default parameter. Okay, default parameter means if even if you don't pass it, it will make it will still it will be made, but with an empty bracket. Okay, so for a default argument you have to give some default value. Okay, so this is my default argument. If no value is passed to it, it will take a default value of empty list. Okay, so what I have done here is I have done add VLAN bad 10. Okay, and it returns, it appends it to this list and add returns me 10. Okay, now when I say add VLAN bad 20, right, I would want that it should return 10 20 only, right? Because this VLAN list is empty, right? And after this in this empty VLAN list I will add 20 and return, so that the value should only be 20, right? But why it is created 10 and 20, right? So we have to understand that this VLAN list which is created only when the function is first time, not each time it is called, but only when the function is defined. Okay, so when this function is defined and stored in the memory, right? If you have said that VLAN list should be empty, it will create an empty VLAN list and store this variable in the memory. Okay, it will store this variable as a mapping. Okay, and even if you don't call it, right, this variable will be passed between the functions. Okay, every time it won't be empty. Okay, so what is the better way to do it? Better way to do is you have to create VLAN list as an empty as none. Okay, and VLAN list you have to define it inside the function. Okay, whatever is defined inside the function is always new. Okay, that means every time it will run a new fresh. Okay, but if you define it as a default argument, it will not be fresh every time. Okay, it can be carried over. That is important. Now args and quarks, these are flexible parameter lists, right? uh, I'm not discussing this in very much detail. Okay, but this sometime we will see in documentations. Okay, and Python documentations, and maybe sometimes we can use it also. Okay, but these you can go over it, right? So if you don't know, right, while you are building the code, while you are writing the function, you don't know that how many variables will be passed to that basically to that function, right? You can assign, you can use quarks and args. Okay, so based on args and quarks you can send n number or an unknown number of an unknown number of values to that function. Okay, just remember that if you add only a single star, that means args. Okay, this will be collected as a tuple, and if you add double stars, quarks, so it will be in the form of a dictionary. Okay, so it depends on you. Do you want the extra, all the other extra parameters in the form of a tuple or a dictionary? You can use any one of them based on it, based on the requirement. Okay, uh, scope. Okay, scope, I was discussing scope just now, right? For example, this is the scope, right? When I said that VLAN list is created, so what is the scope of VLAN list? Okay, so the scope of VLAN list is not within the function. Okay, it can transcend the outside the function also. Okay, that VLAN list can be, it is present within it is passed throughout the function. If you call that function next time, again the older VLAN list itself is passed. Okay, if you define it like this empty. Okay, so similar thing. Okay, where does the scope? Okay, so the scope in Python is, we can use it the short form LEGB. Okay, so L is inside the current function local, enclosing any enclosing functions, global, top level, built-in Python own built-ins. Okay, so this is a global. Okay, you global as in you created it outside of any function. Okay, so it is global, you can use it in any function. As I said, if you put any value inside a function, it becomes local. That means you cannot access this value from outside the function, okay, or in another function. Okay, so you incremented the local, right? Increment local, but the counter is still the same because the counter is untouched. Okay, you can increase the global counter, right? And that's what I'm saying, global versus local. Okay, and built-in is what your Python built-in built-in things like length, print, right? And all those things. So local is within the scope of a function, and global is anywhere in the anywhere by all the functions we can use it. Okay, now remember that anything in Python is object. Okay, we discussed about lists, dictionaries, all of them in memory are stored as objects. Okay, and function is also an object. Okay, so you can store the function in one variable also. Okay, so for example, here what I have did is, and you can then use map and filter. Okay, which are higher order functions, which higher order functions as in you can apply a function on another function. Okay, so those are called as higher order functions. Okay, so I have this IP address defined, right? And I have this is IP private IP, which will first check whether this IP address is a private IP address. Okay, that means it starts with 192.168, so it is private, basically just normal. Okay, now what I'm doing, I am doing a list of filter. What I'm filtering, I am filtering is private IP address, IP address. That means I'm passing this IP address in this is private I192, right? You see how I have done this. I have not done is private I192 in brackets IP address. Okay, what, because this IP requires one single variable, right? It does not require a list. It cannot takes a list, right? So what I'm doing, I'm looping over this list basically inside this, and I'm passing one by one value into this, and I'm checking whether the whether this is a private IP address. Okay, so filter, what it will take, filter will take two things. One is a function, one is an iterable. Okay, and it will run all on all the iterable values, it will run that function. Okay, so that is the use of filter. Okay, so as I mentioned here, right, it will take a function and iterable. So this is an iterable, list is an iterable, right, and this is a function, and it will iterate over all the list and iterate over that iterable and pass the value one by one to the function and get the output. Okay, next is lambda. Okay, uh, you don't want to define say a proper function, right? You want that I should use this function only once and be done with it, right? So you can say lambda IP starts with 192, same thing which I did here, right? But I did not create another function. I just say I will use lambda, right? And I will say IP, I need the value of IP where IP starts with this, and I have to take the IP addresses from here. Okay, same filter I've used. Okay, so in filter, this is my function, lambda function, and this is my what you can say the items, iterable, right? Then I can do map also, right? Map basically transforms. Filtering is used for filtering, and map is basically used for transformation. Okay, transform anything. Okay, so I want to count the number of dots, right? So I can say in all the IP addresses I want to count the number of dots. Okay, so same thing I did, right? This is a map. The first thing is the function, second thing is the iterable, right? Same function iterable format. Okay, now you can do all these things with list comprehension also. Depends on you whether you want to use list comprehension, you want to do map filter, right? But map filter is used, maybe you don't remember it, but understand it from the perspective that you can see it in somebody else's code, you use in some library, right? And you can use it yourself also. This code looks more cleaner, code looks more readable. Okay, depending on who what is your understanding of it, right? So if you understand it very well, this looks more readable than this. Okay. Next is a closure. Closure is a function that remembers its birth environment. Okay, so closure is a function defined inside another function. So it is a function which is inside another function which remembers the variables of the outer functions. Okay, so as I said, again you talk about the scope, right? So I have this function created make device logger, and inside that function I have another log, right? So this log, for this log, this host name becomes global, right? Because global as in it will always be available, right? But this message becomes local, right, for this function. So what I can do is I can make device logger, and I can create a device logger with one router, right, one switch, and then I can use this log switch one for logging for that specific switch. Okay, so when I will create this logging with this specific log value, right, log basically the variable, the inside one will always remember that what was the parent one, right, the parent host name, right? I will never pass that value again. For example, here I have not passed in log switch one, I have not passed the core switch one or anything, right? But is what it was able to print host name this and code switch one, right, like that. Okay. Next thing is recursion. Recursion is a function that calls itself. Okay, a function that calls itself. For example, this is my topology, right? Core switch, dictionaries, this all. Okay, and this is basically a dictionary of lists. Okay, now I want to list the downstream device. Okay, recursively print every device reachable downstream of device. Okay, so for example, I have this core switch, and inside that core switch I have distribution switch, right? And in that the distribution switch I can see that I have access switch 1 and access switch 2, right? Now access switch 1 and access switch 2 are empty, right? Then I go to disk switch 1, disk switch 2. Inside the disk switch 2 I have access switch 3, right? And inside access switch 3 I don't have anything. Okay, so I have to print it in this way, in that chart way, right? So what I can do is I can recursively print it. Okay, I will say print depth plus device. Okay, this is the device. Okay, and this is depth. Okay, this is empty space times depth. This is empty space. Okay, so this is what you are seeing is starting, right? This empty space, this is basically empty space times depth plus device. Okay, now I say for neighbor in topology dot get device dot empty. Okay, that means till I get the empty values you have to continue getting the topology. Okay, and then again from this list downstream devices I again called this list downstream device. Okay, but now with a neighbor and depth of 1. Okay, so what will happen when doing it, understanding it from how what's happening actually, right? So I passed core switch 1. Core switch 1 is the root, right? Now in first iteration it will pick up dist switch 1, right? It will go in this, it will check whether it is empty, no, right? So it will go, it was depth of 0, right? Now it will go to depth of 1, right? In depth of 1, what is dist switch 1? What is the value of dist switch 1? Access switch 0 and access switch 1, 2, right? It printed those, right? After accessing access switch 1, it went into searching access switch 1 value at depth 2, right? This was depth 0, 1, 2. At depth 2 it found that this is empty, so it stopped there. That means that branch stopped, right? But there is some another branch which is with access switch 2, right? So recursion you have to understand from branching perspective, right? First there is in the top there is two branch, disk switch 1, disk switch 2. Inside disk switch 1 there is again two branch, access switch 1, access switch 2. Inside the another side disk switch 2 there is two branch, one branch access switch 03, right? And inside those branches the leaves are empty, so there it stops. Okay, so how it printed? Disk switch 1, access switch 1, empty, access switch 2, empty, right? Then everything ended here because disk switch 1 ended, so it again went to the core. Disk switch 2, disk switch 2, access switch 3, access switch 3 is empty, so like that it printed. Okay, so recursion is not so easy to understand. It is a little bit complicated topic. Okay, it takes time and a little bit more programming to understand. Okay, so you take this understanding, basic understanding, okay, and go ahead and do some take some problems and solve it using recursion. Okay, you will find some problems online. Okay, and it is actually a good way to solve a lot of problems. Okay, a lot of what you can say algorithms are written using recursion. Okay, so yeah, now this is it. Okay, so we discussed the data structure and the functions. Okay, as I left with a practice in switch in lesson 1, same way I will leave with one more practice, coding practice for lesson 2, for which will discuss the results and the how to do it, which we'll discuss in lesson 3. Okay, in the beginning of next session. Okay, but I would like that you try this problem on your own. Okay, so I have the output of show IP interface brief, right? I have this output. Okay, and now I want that you take this output and you find how many total interfaces are there, how many interfaces are up, how many interfaces are down. If those interfaces are down, what is their names, and how many unique IP addresses are assigned to this in this output. Okay, so these are my this is my output. No, I have not shown the output of this, but this is my normal. I printed this, right? So I want total number of interfaces, right? For example, 0, 1, 2, 3, 4, 5 interface. How many of them are up, down? How many unique IP addresses or how many IP addresses I'm using in this? Try to use data structures. Definitely will you have to use dictionary, list, set I can see because I can see unique, right? But try to you make this whole code modular. Okay, modularizing using functions. Okay, so that we can practice both functions and all the data structures as well. Okay, and with this we'll wrap up lesson 2. Okay, starting off lesson 3 we'll discuss about the solution of this, and then we'll move ahead with all the topics from lesson 3. Thanks for watching this video.